Welcome one and all to the video on law of sines, where you will learn to solve the measurements of a triangle through this particular law. The law of sines can be applied to this case, where if you are given one side and two angles, either in the axiom of side angle angle, SAA, or angle side angle, ASA, and this law can be used to find all three other missing measurements given in this form. Now note, according to the law of sines, the length of the sides in a triangle are proportional to the sines of the measures of the angles opposite them. So for example, we have this particular proportion where you're comparing A with B, but A is corresponding with its opposite angle, and not just its opposite angle, but the sine of that angle. So A is going to be over sine A, and you compare it or equal to B over sine B. So that's one of your first proportions. You have a second one where you compare A and C together, and you compare B with C. If you want to put it in simplest form and compact form, you put all three of them together, but again, you have to pick two of them instead of equal to each other to find the missing side or angle given three of the pieces of information. Now in practice, an alternative form can be given as well. So the original is where the side is over the sine of the opposite angle, but the alternative is where you can flip it and you can do the sine of the angle over the opposite side. It is a good strategy to select the proper form where you put the unknown variable in the numerator. So for example, if I wanted to find the missing side given two angles on the other side, then I would use the original. However, if I want to know what the missing angle is given two sides and one of the angles, then I would use the alternative form. So always put the missing variable on the numerator so that it makes your life a lot easier. Can you still solve it if the unknown variable is in the denominator? Yes, but it's just an extra step or two. So let's just dive right into our first example where we're going to be given side angle angle, SAA. So this problem literally says solve triangle ABC if angle A is 32 degrees, B is 81.8, and side A is 42.9. Now there are no directions about how we are to round the decimal answers. So notice that all of these have at least the 10th decimal. So there's one digit after the decimal point. Then that means our final answer should also be the same. First thing you always want to do is draw the triangle. So here you go. I have the triangle drawn, A, B, and C. I was told that angle A is 32 degrees. Remember, that's opposite side is A, lowercase a. Angle B is 81.8. Its opposite side is lowercase b, and the C was C. I also labeled all the correct measurements that was given to me. So the first thing you always want to do is, hey, I'm given two angles. That means I should find the third angle. So I'm going to use the sum formula, the angle sum formula. So I say, all right, ABC equals 180, A plus B plus C. Replace all the variables with the known values. So I plug them in. I combine like terms on the left side, and then I get C by itself by subtracting 113.8. So I get that angle C is 66.2 degrees. So that is one of my angles. So there's one out of three missing pieces I need. But again, I'm not done because I now can find B and C, the sides, the two sides I don't have. So I completed my missing angle, the one I just found, into the angle C, and now I can find one of the sides. So let's just say I want to find side B. Given side A and sine of angle A and sine of angle B, I can use the law of sines where I'm going to put the missing variable B over here in red. Now I can substitute the given values. So I plug in the correct values for each one. So again, 42.9 over sine 32 degrees equals B over sine 81.8. we want the variable by itself, so we're going to multiply both sides by sine of 81.8 degrees, and we rewrite it like this. So now it's 42.9 times sine 81.8 over sine 32 degrees. So, because remember that when you multiply both sides, the sine cancels out on the right side, but on the left side, it multiplies with the numerator. And now this is where I will literally just approximate it with the calculator. So everything that's in green on this left side, where it's equal to b, I will literally just type that into decimals exactly the way it is. Make sure the calculator is in degrees mode. I do have a separate video just kind of showing you how to change it to degrees mode if you don't know how. So the final approximate answer is 80.1 centimeters. Don't forget the unit of measurement. So like when we find angle C, we said it was 66.2 degrees. This one's the side, and I knew it had to be in centimeters because one of the sides was in centimeters. So we're almost done. We just now can find C. So again, I updated my triangle. So I have 5 out of the 6. So I need to find the missing side. I use the law of sines again because I know one side and I know 2 angles that correspond with it. So I have A over sine A, C over sine C. Substitute the known values. Oops. Multiply both sides by the denominator that has the side with the unknown variable. I put that into my calculator, and I get the final approximate value of 74.1 centimeters for the C. And we are finished. We found all measurements for the triangle. And there you go. So that's an example of solving a triangle where you're given 3 of the 6, and you can use those 3 to find all 3 of them if it's the axiom of SAA. See what happens if it's ASA though, angle side angle. So here we have Jerry Keefe. He wants to measure the distance across the Big Muddy River. We have angle C, angle A, and side B given to us, and we are specifically wanting to find the distance of A. So to always make sure we have everything covered, we always want to find the missing angle. And we really need it in this case because we can't really apply the law of sines yet. So we're going to find the missing angle first. So here we go. I get the 2 angles replaced with the correct values. I solve for B by itself, and I get that B is equal to 36 degrees. Now that we have our missing angle, now we can find side A. So I use the law of sines, and I'm going to use the proportion of A and sine A compared with B over sine B. The reason why I can do that now is because I found one complete pair. Okay? You always need one complete pair. Previously, we didn't have it at the moment. We never had a, for example, angle C with side C. So we needed to find a complete pair, which was in this case right there. Substitute the known values. Multiply both sides by sine of 31.1 degrees. Put this into the calculator, approximate it, and if we round it, we're going to get side A is 305.5 feet. So that is the final answer because that is the distance from the river that we wanted to find. And there you go. That is how you apply the law of sines to those 2 cases, ASA and side angle SAA.